here's a really cool question. It says triangle ABC has these sides, this one, and this one. So what do you do? Well, just draw the triangle. The triangle is very, very simple. Draw any kind of triangle at all. A, B, C. There, label it. Perfect. Once you've labeled it, and I don't care how you label it, I don't care where you put the A, the B, or the C, but just label it. But once it's labeled, then everything else is set. Because if that's angle A, that is side A at 26.32 right there, babies. And if you look over here, there's angle B, that's got to be side B right there. So that's 30. If this is C right here, then guess what? This is side C. Yes, C at 35. Perfect. Excellent. Now, think about this. It's asking you to determine all of the angles. Well, I know you want to go out and use sine law right away, but I want to show you why sine law doesn't work. Because you got sine A over A, sine B over little b, and check this out. You need at least one angle, right? You need at least one angle to find either this one, or this one. But you don't have any angles, so that goes out the window, okay? Now, so what can you use? Use cosine law. Pick A, for example. If you know this is A, this A goes with this A right here. They have to go together. So using cosine law, you're going to find angle A. So since this is cos A equals 2, you know something's going to happen to this cosine afterwards, okay? We'll figure that out as we go. But that equals to this. Think about it. That guy and that guy go together. And according to the formula, if you remember, the formula on the outside, those are the ones that go together. A goes with little a. And little a, if you remember, is that one that is subtracted. So after all this is said and done, you have to subtract that guy out. The rest of it is really, really, really simple. Think about this. What you got here is this. You've got that squared, so you got a side here at 35 squared. You add it to the side here, which is 30 squared, and you're going to subtract it from this one right out there. Then, don't forget, you have to divide this by 2 times 35 times 30. So what you have to do now is throw this all into your calculator. Now, I know what you're thinking. This looks really complicated to put in a calculator. Well, it's not. The reason why is you try to do one thing at a time. The top, you do once. Then, once you figure out the answer for the top, then divide it by the bottom. Okay, so how are we going to do this? Well, let's go into our calculator and see. So I got my calculator running here in the background, and let's take a look at the numbers again. The numbers again are 35 squared plus 30 squared. So let's put that in right now. 35 squared plus 30 squared. There's the number there. You know I'm going to subtract it by that A value that you picked. What was that A value? Let's bring it up. That A value was 26.32 squared. Okay, so 26.32 squared, 26.32 squared, and that's going to give me the whole top. Now, we have to divide it by the bottom. And if you look at this, the bottom is 2 times 35 times 30. Look how the order matters here. That one's first, that one's second. That one's first, that one's second. Meaning that that's that A term that goes with cosine A. Leave that out. You only see this 35 and 30 twice. That's kind of a little interesting thing to know about cosine law, okay? All right, so throw that in there. 2 times 35 times 30. Let's bring up the calculator. Now, you're going to divide this by, now it's important right here, and this is where students make the mistake. You have to put a bracket here because you're dividing by everything. So it's 2 times, what were the numbers again? 35 and 30. Okay, 2 times 35 times 30, and put the bracket around that. That means if you look at this, that means this whole answer here is going to be divided by that whole thing in the bottom. That's one of the reasons why we put brackets around it. So let's put enter here. Now that is 0.682. And you remember, that's what your cosine equals to. The cosine of theta equals to this number. So obviously, this is that last step that you have to remember to do. You have to remember to inverse cos to both sides. That way, you cancel out the cosines and you get theta equals to. Okay, so let's inverse cosine. Let me clean this up so you can see it a little nicer. Inverse cosine, here we go. Second cosine of the second answer. There's that answer, 0.6820. Throw into our calculator there, and we hit Oh, look at that, 46.99. That looks close enough to 47 degrees. So let's just leave it at 47. So that means our angle A, now let's get rid of all this stuff. Whoa, our angle A here, was, what was it? Let's bring it up just to make sure, 47 degrees. Cool. So that's 47 degrees, making this a whole heck of a lot more fun. Now, I'm going to clean this up so that you can see it now. There's our original triangle right down there. Let's get rid of this. Let's get rid of that. Let's get rid of this. Let's get rid of this. Now, do you remember what I said about sine law? Do you remember what I said about sine law? You need at least one angle. Well, guess what? You got the angle. You know what? I think I'm going to just redraw this triangle entirely. Here we go. We know this is 47. We know this is A. We know that A is 26.32. We decided this was going to be B here, and B up here, of course, is 30. This is going to be C out here. This is going to be 35. Check it out now. Now that you've got these beautiful numbers in here, you can actually find the angle C, and that's all you really need to find, because using the sine law, because once you know this angle here, subtract it from 180 and you got your third angle there. So here's where you're going to use, guess what? Sine law. Okay, so check it out. This guy again goes with that. All right, so sine of 47 degrees goes with your 26.32. Excellent. Sine of what? Well, let's find the sine of this guy. Let's find the sine of C, which again goes with 35. Pretty simple. Multiply those out, cross multiply, divide by the guy that remains. So, okay, here we go. We're going to go the sine of 47 times 35. Let's bring that up. Now, the nice thing about not clearing your calculator is, remember, we rounded to 47. There's the exact number there. Works perfectly. So I'm going to use that. And remember what we're going to multiply. 35 times 47. So 35 times the sine of this guy right there. Boom. Let's just pop him in there. There he is. Da-da-da. That equals to this. But we're not finished yet, because remember, we have to divide by 26.32. So let's bring this calculator up. Divide by 26.32. 26.32, we get a number that looks like that. And don't forget to find the actual angle. We have to, guess what? Second inverse sine of that guy. There we go. And here comes our angle. Ready for that? Bing! It's 76.5. How sweet that is. Okay, so this we know, angle C is 76.35 degrees. Now, all we have to do now is find angle B. There it is. And don't forget, if you've got this angle and this angle, don't forget they can all sum up to give me 180 degrees. So there's my 180 degrees. I'm going to subtract out this 47, and what we know now is 76. So subtract out the 47 degrees, added to the 76 degrees that we have here, and we should get our angle B. So again, using exact numbers, and that's what we want to do, is we want to use the exact numbers. So I'm going to use this. Get this guy out of there so it doesn't distract us. There's our 76. So let's go 180, subtract that number. Now wait, before I put that in there, I better put a bracket in there because I want to make sure I combine those two. Okay, so that guy here, added to, where's my other degree? It's my 46, do you remember? It was way, way, way up here. There it is. Add that to that. Put the bracket around it, and this should pop out my other answer, and it's 56.4. Look at that. That makes this guy, angle B, 56.4 degrees, and we're good to go. Now, the cool thing about this podcast is I did it in front of one of my favorite classes, and they're all watching me right now smiling, and they all want to be on a podcast, so I told them they can cheer. This officially is the last podcast of Math 20-1. So let's hear it, guys. Told you.